In this video, you'll be learning how to calculate the circumference of a circle. And before we do that, we need to quickly review some vocab for circles specifically that you'll be hearing a lot. So this first example here, this line that goes about halfway through the circle, so from the outside to the center, is called a radius. A lot of times you'll just see it as the letter R. If it goes the full way across here in number 2, so from end to end passing through the center, that's called a diameter. And you'll be seeing the letter D. And then finally, the distance around the outside of that circle, in a lot of other shapes, we call it a perimeter, but for circles, we call it a circumference. And you probably guessed that you'll be seeing the letter C. So a common theme with circles is that they're weird and they really don't follow the kind of norms that other shapes do. So our first example of that would be a perimeter. That's the distance around any other 2D shape, and you get it just by adding together the sides. So for this rectangle here, I could find the perimeter by doing 3 plus 5 plus 3 plus 5. You might think of some shortcuts you can do, and that's fine. But either way, the perimeter is 16. For this triangle here, I would do the same thing of 3 plus 4 plus 5, and here that gives me a perimeter of 12. So there's our first problem. Circles don't really have sides, so to find the perimeter, or here the circumference, I need to figure out a different way to do that. And that's what this video will teach you. So let's look at some of your findings from the measuring challenge from Monday. If we look, I just pulled 4 from the doc and I checked it at like 5 o'clock. So this is just some highlights of those of you that did it. If you look, Mark did a cookie lid, and when he did circumference divided by diameter, he got 3.138. Biscuit got 3.15. Cameron got 3.077, and Anna got 3.2. And if you take a look at that doc, a lot of these numbers are super close together, and they're all kind of in that 3-point-something range. If we look at all of these specifically, they're really close to a certain famous number in math. And especially like if we look at Mark's, they're all really close to pi, which we know is 3.14159, so on and so forth. So I encourage you to take a look at that doc and see how many are in the 3.1 something, 3.2 something. So what that tells us is that the circumference divided by diameter is where pi comes from. So the number pi, it wasn't necessarily created, it more just exists in every circle. And it's equal to the circumference of that circle divided by its diameter. And we'll talk more about this number next. So what we found from measuring different circular objects was that if you take that distance around the outside and divide it by that distance in the middle, no matter what type of circle you have, you'll get pi as that answer. So we actually use what pi is and how it's found to create the formula for circumference of a circle. So we're going to look right here. And the goal is to get C by itself. So the goal is, how do I calculate circumference? So let's think about this in terms of an equation. Right now, this is C divided by D. So if I wanted to get C by itself, or isolated if we were fancy, I would want to get rid of dividing by D. Well, the inverse of that would be to multiply by D. So by multiplying both sides by D, I would get C by itself, and that would be equal to taking pi and multiplying it by the diameter. So believe it or not, that's the formula for calculating circumference. We take that circumference by getting pi times the diameter. So again, D here represents the diameter. So I'm going to show you a couple examples using that formula. So here in these two examples, I have the diameter of each circle. The first one says 5, and the second one gives me my diameter is 7.5. I know those are the diameters because they go the full way across. So I'm going to use this formula of C equals pi times D. And here, that diameter is what value I'm going to put in place of the variable D. So in this first one, I have pi times 5. And in the second one, I would do pi times 7.5. Now, believe it or not, there's actually 2 ways to write your answer. And the first would be in terms of pi. So in terms of pi is really nice if you don't have a calculator or you want to avoid the really long decimal that working with pi is going to give you. And all you do is switch the order around and write the number first. So instead of pi times 5, in math we write the number first. So my answer here would be 5 pi. So for the second example, again, leaving it in what's called in terms of pi, my answer would be 7.5 pi. And that's it. Now, let's say you didn't want the pi symbol there or you actually wanted to multiply it out. Your other option would be to actually round and to get a decimal. A lot of times you'll be told to use 3.14 for pi. So if it wants the decimal, you would actually grab your calculator and do 5 times 3.14 and get an answer that way. So for this example, I would get 15.7 as my circumference. And for the second one, I would do 7.5 times 3.14. And let's see, that one gives me 23 and 55 hundredths. Now what's important to note is that either way you write it, those are technically the same thing. They are equivalent to each other. And it's kind of like a fraction and a decimal. 1/2 is the same as 0.5, they just look different. So here we have 2 options of how to write our answers depending on, do we want decimals or do we want to try to avoid the decimals? And we'll see this more and more. So next we're going to look at, well, what if instead of having the diameter, I have the radius? Can I still use that to calculate the circumference? And the answer is absolutely. To do that, we're going to figure out just how the radius and diameter are related, and then we'll figure out a new formula to use. So if I look here, right now I have 1 radius. And to go the full way across, I would need another radius. Remember, the plural of that is radii. So what I'm saying is it takes 2 radii to give me 1 diameter. So what that means is that instead of d, I could use 2r. So here, before where I originally had the variable d, I'm now going to put 2r because those are the same thing. But I don't know about you, this looks awkward. So we're just going to restructure it a little bit, writing the number first. So the 2 will come first, then the pi, then the r. So our second formula for circumference is 2 times pi times the radius. You'll hear me say 2 pi r. So let's take a look at using that. So we're going to start off the same way we started with the other formula. The difference here is I now have that 2 in front of my formula. So here I'm given the radius. I know it's the radius because it only goes halfway. So each of those values is what I'm going to use for the variable r. So I'm first going to start by plugging those numbers into my formula. So 2 times pi times r, and here I'm going to put 3. And in the bottom one, I'm going to have 2 times pi times r, which here is 12.5. We can still write these 2 different ways as well. So the first way of in terms of pi